All right, so this is March 20th. Okay, so from last week, can somebody just give me the rundown here? What's a Cartesian vector? How's that different than the previous unit? What's the difference there? Because I don't recall at all.
The way that you'd write it is got the name of the vector and square brackets with the x change and y change.
Yeah, so let's say I do that, 3, 4. What does that mean? Similar than Derek, am I going to go around and do Spider-Man again today? So I do recall what that means, the square brackets? Sort of. Somebody help her here. Does anyone remember? No, that's okay. It's going to be a vector from 0, 0 to 3, 4. So basically everything here can be graphical. That's basically what we're saying here. Okay, so it's going to be, the idea is you're starting from the origin, which is 0, 0, going to 3, 4. All right, so let's talk about the dot product quickly. Okay, the dot product. Here's my diagram. There's B. This whole thing's A. Okay, so we're going to say for two vectors, A and B. I apologize, this is heavy, noteworthy. The dot product is defined as A dot B equals magnitude A, magnitude B cos theta, where theta is the angle between A and B. When arranged tail to tail, and 0. Let me go the other way here, and we'll talk about this. So we're starting the scalar into a vector multiplication. That's what this is starting into. Okay. So what we're doing here, and I'll just talk you through as you're writing there. Okay. Because this is something that even as a student I had a little bit of a tricky part. What you're going to do is you're going to take the A component of the B vector, and then you're going to multiply the magnitude of that with the whole of A. Okay, that's what we're doing here. Okay, so instead of you're taking B, B is going to be a weird vector like this. You're just going to drop it down like it's a shadow. Think of it like that, or like the A component of it, and then multiply by A. That's what we're doing here. Okay, we're going to say then the dot product is a scalar and represents the number of times the horizontal component of B is multiplied by A. I'm going to get out of the way here. And we're going to do this with Cartesian vectors and with regular vectors. Okay. Why is this going to be more difficult with Cartesian vectors if you had to guess? So I'll give you a second to scribble, then I'm going to pick on Matt. Matt, why do you think this would be easier to do with like north, south, east, west vectors? Somebody help me here. Why is north, south, east, west going to be easier in this case? Well, think how easy it is to get theta, right? Theta, you're just going to be able to find them and compare the two vectors and get the angle between them very, very easily. If we have vectors that are like based on Cartesian, we're going to do a little bit of math to get it, okay? But luckily this works out beautifully. This is one of the days that calculus works out nicely for you, and things are going to be good for that. Okay, so just so we're clear, I want to make sure everyone gets the concept before we continue. So what we're doing is basically finding the, again, horizontal component, I called it B. It's going to be this and multiplying that by A. We're okay on the logic there so far? Let's do it. Ready? Yes? Emma, wide awake, close up? Good. That's all I like to see. Brandon, all well?
Oh,
Your hair is less. Did you get a haircut? By the way, if you think it's awkward to be talking about Brandon's hair, just somebody let me know on the way out of the class so I'll stop doing it. Example 1. If vector u equals 20 north, 18 degrees west, and v equals 30 north, 39 degrees west, find u dot v. Okay. All right, Nathan, I'm going to pick on you. If you don't know how to start this, what's always a good thing to do with vectors if you don't know where to begin? Draw it. Just probably makes sense to do, okay? Because we'll be able to find what the theta is very, very easily when you see it out. Okay. Now there are people that would say, yeah, I'm just clearly it's going to be 21 degrees and whatever, and do their thing, okay, right? But for most people, most human beings can't do that, okay? So the u vector I'm going to do first, which is going to be in black. So it says north 18 degrees west. Okay, so there's 18 degrees, and that's going to be a distance of 20. Okay, so everyone see how that came about, hopefully? Right, so you're starting north, James. Bailey, thank you for correcting me right now rather than waiting until the end of the question. I'm glad you're here today. It's not that I've gotten up with. Thank you. I do, I appreciate it. Thank you. Okay, so that's U. V then is going to be 30 degrees north, 39 degrees west. So here we go. That right there is going to be 39 degrees. And that's going to be a distance of 30. All right. Hannah, for my picture, what do we actually need? What angle do we need to find in order to get dot product? Look back at the diagram if you need to. What angle do we need? The one between them, very good. Okay, so this is going to be your theta, it's going to be between these two, right? Okay. Are we okay on the logic here? Nathan, we're sort of okay on the logic? Okay, great. So Cecilia, what's theta going to be? Oh, sorry? What's it? Go ahead. 21. How'd you get that?
Because 39 minus 18.
39 minus 18. So right, if you have the blue vector, so pick the blue vector one over here, that's 39, right? And then 18 there, so theta is going to be 21 degrees. Okay. James. Back from the definition, what's the definition of dot product? What's the equation going to be, please? Yeah, go ahead and delete your notes, that's okay, buddy. Yeah, so I'm going to call it U and V in this case. Okay, right, so I just did there magnitude U, magnitude V, cos theta. All right, Alistair, what is the magnitude of U, please?
20.
Good, what's the magnitude of V?
30.
And what is theta? 1 degrees, perfect. Yeah, question, go ahead. That's what's just a dot product. That just shows that we're not really multiplying, because there's two different ways we can multiply vectors, right? So this is that just showing you that it's like a multiply. Okay, but so we're using dot product for that. All right, Emma, can you get your calculator out for me, please? And when I say Emma, I mean everyone in the class. So please calculate that for me, please, and hopefully you get the same thing I get. I didn't hear you, but I think you said 560. 114, I hope. 148. Okay. I'm having a rough start. Look, I can't even print on the word here. I'm having a rough start to the day here. On 1.5. All right. Do you guys want another one, or you're feeling okay about that idea?
And since it's a scalar, we don't put the direction.
There's no direction, right? There's no direction, just a scalar, right? Is there an equation in physics that looks like something cos theta? Is it like work or something like that, or anyone here in physics? No, they haven't seen that yet. Okay, there's one that is related to physics. One of these. We'll get to that later on in the course. So, are you okay with the idea of the diagram going then to the multiplication? That's all this one is. So far, so good. Yes. Okay. All right, properties of the dot product. Okay, if those two vectors are at a right angle, what's the horizontal component of U going to be in this case? It's at a right angle. 0, right? So therefore, if U and V are perpendicular, U dot V equals 0. And that's going to be useful also for, that's probably one of the biggest things that we're going to use the dot product for. It helps you to prove perpendicularity. I'm going to pretend that's a word. It helps you to prove the two vectors are perpendicular. Okay? U dot, also we're going to say that U dot V equals V dot U. Okay, no one took me up on this on the first one, but they said, well, is it going to be basically we're saying, are you going to drop the 20 down to here, or are you going to drop the 30 down to here? It doesn't matter, it's the same idea. Because if you take a look, you're just multiplying your two scalars, so you can easily flip that. There's not going to be a distance difference. And finally, U dot U equals magnitude of U squared. I'm not going to prove those, but that's okay. I'm going to do a few more rules, then I'm going to take a break, and then we're going to move on to Cartesian. Okay. Are we okay on the logic here, what we're doing here, sort of? A little bit? Yes? Okay. All right. Finally, let's go. We're going to say for any vectors U and V and KER, KU dot V equals KU dot V equals U dot KV. Doesn't really matter. Any one of those will be the same. And again, you can think the reason for that is, right, it's just gonna be another coefficient multiplied, into the equation. And the distributive property is gonna go, U dot V plus W equals U dot V plus U dot W. And there's gonna be our last one here. I'm gonna take a little break.
Where did W come from?
W is just a new one, though I can write it for me. Just for you, Billy, I'll read it normal. I just made another vector this.
So the top one, it just means that all of them are just equal to each other.
Right on. Yeah. So again, just like if you're multiplying one of them by 3, it's the same as multiplying this one by 3 or this one by 3 or the result by 3. That's all I'm saying. Okay? I'm going to hit pause in the video. Then we'll do some more examples.